Imagine holding a simple teaspoon between your fingers. A common spoon, just like the ones we use to stir coffee every morning. Now, try to conceive something even more impressive. This spoon, filled with a mysterious material, weighs more than the entire Mount Everest. A little spoon, heavier than the tallest mountain on Earth. What could be so dense, so unimaginably heavy? Welcome to the universe of neutron stars, the densest material ever found in the cosmos. When a massive star reaches the end of its long and bright journey, it does not disappear quietly. Instead, it explodes in a colossal supernova, one of the most powerful demonstrations of energy in the known universe. During these cosmic explosions, almost all of the star's matter is ejected into space, enriching entire galaxies with heavy elements. But what remains at the heart of the supernova is the real secret, a small core, compressed to the limits of the laws of physics. This core is what we call a neutron star. To understand why a neutron star is so extraordinary, we need to dive into the subatomic world. Under normal conditions, matter is composed of atoms, small structures, almost entirely empty, where electrons orbit around a nucleus of protons and neutrons. But under the unimaginable pressure of stellar collapse, these atoms do not survive. They are crushed with such force that the electrons are forced to merge with the protons, forming neutrons. It's as if the entire atomic structure collapses, leaving only elementary particles squeezed side by side. The neutrons, now together, occupy an incredibly small space, forming a material so dense that it defies our understanding. Imagine an atom being disintegrated, its internal parts collapsing until only a compact soup of neutrons remains. This is the secret of the absurd density of neutron stars. There is no empty space between the particles. Everything is compressed to the maximum. The result? A material so heavy that if you could somehow take just a teaspoon of it, it would weigh up to 6 billion tons. That's right, a teaspoon with 6 billion tons. For comparison, Mount Everest, the tallest mountain on the planet, weighs about 161 million tons. A single teaspoon of neutron star is dozens of times heavier than the entire mountain. If it were possible to bring it to Earth, it would sink kilometers into the Earth's crust, crushing everything in its path. But the surprises don't stop there. A typical neutron star contains more mass than our own sun, but all of it in a sphere only 20 kilometers in diameter. To visualize, imagine shrinking the sun, with all its light and energy, down to the size of a small city. The gravity on the surface of a neutron star is so intense that any nearby object would be instantly crushed. Even light, which normally travels in a straight line, bends around these stars due to the extreme gravity. Physics stops working as we know it. Time slows down. Space warps. The impossible becomes real in the face of these cosmic forces. And where, after all, are these neutron stars? They are not common, but they are also not as rare as we imagine. Scattered throughout the universe, we often detect them as pulsars, neutron stars that spin rapidly and emit regular and precise beams of radiation. Like cosmic lighthouses, these pulsars spin hundreds of times per second, sending signals that travel across the galaxy and can be picked up by radio telescopes on Earth. Each pulsar is a reminder of the titanic forces and violent events that shape the universe. When we look at the night sky, we see distant stars, some already dead for millions of years. Perhaps among these points of light, there is the echo of a supernova, the silent glow of a neutron star, lost among the constellations. The universe, in its vastness, is much stranger and more fascinating than we ever imagined. It hides secrets on scales of size, time, and density that challenge our imagination and remind us how small we are in the face of it all. The next time you look at a simple teaspoon, remember, somewhere in a distant corner of the cosmos, there is matter so dense, so incomprehensible, that the spoon itself would be unable to support its weight. Remember neutron stars, relics of supernovas, guardians of the secret of extreme matter. These exotic objects show us that the laws of the universe go far beyond our everyday life, revealing a world where the impossible becomes possible. Did you enjoy this cosmic journey? Keep exploring the mysteries of the universe. Leave your like, subscribe to the channel, and share this knowledge with those who are also fascinated by the wonders of space. After all, the more we learn about the cosmos, the more we realize that we are just beginning to decipher its enigmas. The universe is full of extreme phenomena, and each discovery is a window to new horizons, inspiring us to look up and dream bigger.